Okay, in this video, I'm going to discuss what it may look like to be using empirical values, so the values that are listed above for Bolivia, coming from our Bolivia program, versus what we've been using before, which were more so, I'd call geometric values. So we were making guesses based on geometry, reasonable guesses based on geometry, but now that we have solid data from our programs and how much material is actually going into these components of the structure, we'll start using these values. So I have this little table here. Previously, we were assuming that 20% of the masonry walls were mortar and 80% of that was rock, and 15% of our fill was mortar or grout, and that 85% of that was rock. Now that makes sense, right? The walls are much slower to make, and they are going to be more dense with mortar in between the rocks. So there's going to be a higher percentage of that structure that's coming from mortar. So we're going to be using more mortar. And the fill is rocks with the slurry mix in between it, but it's not going to perfectly fill the voids like we get in the masonry walls. So there's going to be less grout and more percentage per volume of rock. So doing that, the equation should have looked like, say for a wall, 20% times volume of the wall times however many kilograms cement per volume of masonry wall, or kilograms of masonry wall, and kilograms of cement per masonry fill. Now we can do a dimensional analysis there to make sure we're doing everything right, but that is the general form of the equation. But now the equation should look like this because we are changing those values. And that's an example using concrete, or using cement rather, and I'll include another example below for using sand or gravel or the rock in the masonry walls to see how those calculations differ. But just as a reminder, this would be the new form of the equation, right? Because in using this empirical value, we are eliminating that 20% assumption. We are going straight to the source, and we're saying that per volume of masonry wall, or per meter cubed of masonry wall, we know we're going to use 80 kilograms of cement. So this actually makes the math easier, but you just got to make sure that you're not also adding that 20% into the equation that we had from before, or else you'd be severely undercalculating the amount of cement you need.